Hello, in this video, we see the FM transmitter block diagram and working by Somnath Mondal, roll number 34900321012, Department of Electronics and Communication Engineering, Kuchbihar Government Engineering College. Now, for FM transmitter, we have to know FM and transmitter both. Now, FM, frequency modulation. FM is a system of modulation in which the instantaneous frequency of carrier is continuously varied in proportion with the modulating signal. Means carrier signal is continuously varied. Instant carrier signal frequency varied with the modulating signal. In this image, we can see that the first one is a modulated signal, second one is a carrier signal, and the last is a modulated frequency or frequency modulated signal. Here we can see that the amplitude of the carrier signal is same in the frequency modulated signal. Only the frequency of the carrier signal is changed with the modulated signal. This is the later here. The amplitude of the carrier signal remain constant, so that information is conveyed via frequency changes. If we in this figure we can see that to generate a FM wave, we can send a modulated signal or audio signal to a integrator. Then it will be go to phase modulator, where it modulate with a carrier signal which is coming from a oscillator. Then it will make a FM wave. The modulation index is denoted by H, equal to del of F by F of M, where F of M is the frequency of the message signal, and the del of F is a constant into E of M, where E of M means the amplitude of the message signals, and we can write it del of F by 1 by I2S, equal to 2 del of F into Ts. Next, transmitter. Transmitter is a set of equipment used to generate and transmit electromagnetic wave carrying message or signals. Means a set of equipments which are used to generate and transmit electromagnetic waves. Now, the term transmitter is usually limited to equipment that generate radio waves for continuous purpose or radio locations such as radar and navigation transmitter. Means and now so the equipment for the transmitter is sound signal, input transducer, preamplifier, modulator, power amplifier, and antenna, and a carrier signal or oscillator. A signal will be come and in input transducer, then it will be converted into the audio frequency, say convert into the electrical signal, then it will be go to preamplifier, then it will be go to modulator and modulate with a carrier signal and go to power amplifier, then antenna it will be transmitted in the form of electromagnetic waves. Next, FM transmitter. In FM transmitter, the signal transmitter and generation both are not same. Means transmission and means to the process of transmitting a signal or wave, or generation means the process of producing a signal. Means in transmission, a signal will be transmitting to a long distance or else. But in generation, a signal will be generated, then it will be transmitted or something else. So the generation and transmission are not same. Now, FM transmitter is a low power transmitter and it uses FM wave for transmitting the sound. The transmitter transmits the audio signal through the carrier wave by difference of frequency. The definition of the transmitter is the transmitter which is used for transmitting the frequency modulated wave is known as FM transmitter. Or we can say this, the transmitter which is based on frequency modulation technique is known as an FM transmitter. Or if the transmitter which take audio signal as input and delivers frequency modulated wave. The range of the frequency transmitter is 88 MHz to 108 MHz. We can classify a FM transmitter in two types. One is direct FM transmitter, another is indirect or Armstrong FM transmitter. Now, direct FM transmitter. FM transmitter circuit is used to produce and transmit the radio frequency signal wirelessly. Working of the direct FM transmitter. Now, at first see the block diagram of the direct FM transmitter. The direct FM transmitter consists of microphone, preamplifier, a modulator, RF power amplifier, and output filter and antenna. Now, see the working. The following block diagram shows the block diagram of the direct FM transmitter, and the required component of the FM transmitter are microphones, audio, preamplifier, modulator, oscillator, RF amplifier, and antenna. There are antenna. These all equipments are seen in this block diagram. Now we can see that the There are two frequencies in the FM signal. The first one is a carrier frequency and the other one is a audio frequency. The audio frequency is used to modulate the carrier frequency. The FM signal is obtained by differing the carrier frequency by allowing the FM. The FM transistor consists of oscillator producing RF signal. Means in this block diagram we can see that in this modulator two signal is coming, one from crystal oscillator and another from this preamplifier. This is written here that there are two frequencies in FM signals. The first one is carrier frequency and the other one is one is audio frequency. Now in next point, the in the first block diagram, this is the microphone. Means this is the microphone. This microphone convert the audio signal or voice signal into the electrical signal. This transducer which can convert into audio signal in the form of electrical energy. So microphone is a source of audio signal. Next block diagram is audio preamplifier. Audio preamplifier is used to amplify the audio signal coming from the microphone. This is the preamplifier which the audio signal coming from the microphone, it will be amplified. Then it will be sent to the modulator. Now next one is the modulator. The modulator circuit is the main part of the FM transmitter circuit and it converts the audio signal into the radio signal which is to be transmitted. The modulator circuit takes two signal as input. One is the audio signal coming from the microphone and the other is a carrier signal. Means we see first that the two signal comes. One is from there and another is from here. This is carrier signal and this is the audio signal. These two signals coming at modulator and they and the signal which will be make the audio signal into radio signal. Now we can see the RF power amplifier. The modulator circuit modulate the RF signal according to the audio signal and produce the modulated RF signal as the output. Modulator signal modulate the signal and produce the output at the RF power signal. Then the modulated radio signal coming from the modulator circuit has a low amplitude, so it cannot be transmitted for a long distance. And here we can see that the signal coming at the modulator and here the resultant modulator signal is not, it has a low amplitude, so it cannot be transmitted to a long distance. So here we use a RF power amplifier which will be amplified the signal and it will be can be transmitted for a long distance. So RF power amplifier should be used. Then the amplifier radio signal is fed to the antenna for the transmission of signal. Then the signal will be sent to the antenna. Then signal goes to the output filter which will be reduce the noise and go to the antenna which will transmit the signal. Now the Armstrong FM transmitter. Armstrong method generates double sideband suppressed carrier signal, phase shift this signal, then insert the carrier, the produce the frequency modulated signals. Mills Armstrong method generates double sideband suppressed carrier, which can be known as a DSSC. This passive signal and that will be reinserted to produce a frequency modulated signal. In this block diagram, we can see it that this is the block diagram of the Armstrong transmitter. Here the DSSC will be created or generated, then it will be sent to the frequency multiplier. Now see the working principle of this is Armstrong transmitter. Armstrong transmission consists of the balance modulator, crystal oscillator, adder, 90-degree phase shift of the crystal oscillator or carrier signal, and the frequency multiplier, difference mixer, frequency multiplier, and the antenna on power amplifier. Now see the working principle of this Armstrong FM transmission. It should be noted first that the output signal from the carrier oscillator is supplied to the circuits that perform the task of modulating the carrier signal. Means first output signal from the carrier oscillator is supplied to the circuit. Then the oscillator does not change the frequency. At the case of direct FM, this point out of the major advantage of the phase modulation or indirect FM over direct FM. That is the phase modulator or crystal control for frequency. Means here we can use a phase shifter, 90-degree phase shifter, which can be phase shift or we can say it the delay the carrier signal, which cannot be used in the direct FM. It will be used in this Armstrong transmission and process. And this will be the, and this is known that this is for the oscillator does not change the frequency as in the case of direct FM. This point out of the major advantage. This is a major advantage. Now see the next point. The crystal control carrier oscillators signal is directed to two circuits in parallel. This signal is established as therefore first carrier signal and is assigned the value 0 degree. Then the balance modulator is an amplitude modulator used to form an envelope of double sideband and to suppress the carrier signal DSSC. The required to input signal, the carrier signal and the modulating message signal. To input signal, carrier signal and modulating message signal, the output of the modulator is connected to the adder circuit. Here the 90-degree phase shift added to the carrier signal. Means here you can see that the balance modulator get to take two input from a audio signal and the crystal oscillator, then it will be goes to the adder. Here adder will be it take an input from the 90-degree phase shift of the carrier signal. Now go to the previous one that we see that the act of the delaying the carrier phase shift by 90 degree not change the carrier frequency or its wave shape, the signal identified as a 90-degree carrier signal. Then the 90-degree phase shift network does not change the signal frequency because the component and the resulting phase change are not constant with time. However, the phase changes are constant with time. However, the phase of the adder output voltage is in continual state of change brought about to the cyclical variation of message signal. Means here the added would be phase delayed carrier signal will be get added with the modulator resultant of the modulated signal. Then it will be goes to the frequency multiplier. Then it goes to different value mixer, which will be one type of adder, and here it will be added with the carrier signal, which is generated from a crystal oscillator. Then it will be again goes to the frequency multiplier, same as the previous one, and then it goes to the power amplifier to amplify its amplitude. Then it goes to the antenna, which will use to transmit the signal in the form of electromagnetic waves, and this power amplifier used for to amplify the amplitude of this signal resultant signal, because resultant amplitude of the resultant signals is not so long to be transmitted a long distance. Now this is the Armstrong transmission block diagram and this working principle. Now the application of this FM transmitter. The FM transmitter are used in the homes like sound system in halls to fill the sound with the audio source. And these are the second. These are also used in cars and fitness centers. Third, these correctional facilities have been used in the FM transmitter to reduce the pressure noise in the common areas. Advantage of this transmitter: FM transmitter are easy to use, large operating range, efficiency of this transmitter is very high. Disadvantage of this FM transmitter: in the FM transmitter, the huge wider channel is required. The FM transmitter and the receiver will tend to be more complex. Due to some interface, there is poor quality in the received signal. Means first, the disadvantage of the first one, that the huge wider channel is required. This is this is a disadvantage, and disadvantage the FM transmitter receiver will tend to be more complex. It will be also a big disadvantage for this FM transmitter. Thank you.